We are live. Hi everyone, welcome back to Code Era. Today in this video we'll be discussing the LeetCode daily challenge for 4th of February. The name of the problem is Contiguous Array. Previously this problem has been asked in organizations like Adobe, Amazon, and it's also been asked in Google, right? So consider giving me a +1 in the chat if my voice is clearly audible to everyone and the screen is visible, and then I'll start with this particular problem, right? It's a very interesting problem which is based on the concept of hash maps as well as you can say prefixSum. So I'll be letting you know like how we have to approach this problem and what will be the optimal approach for solving it. Hi Lalit, what are you saying? वो stream में last में क्या बोला? अरे भाई बाद में क्या बोला? Okay. Hi Shreya, hi everyone. Right. So in this particular video, what we'll be doing is we'll be solving the LeetCode daily challenge for contiguous array, right? So the question is that you'll be given a binary array. So you'll be given an array which will be consisting of zeros and ones, and you have to find the length of the longest contiguous subarray such that it has equal number of zeros and ones, right? So what does the question means? The question means that if you have a subarray like this, let's say you have a subarray like something like this, 0 1 1, like, and maybe you have some zeros, right? So in this you can see that this is the subarray which is of the longest length, and like this length is what? Total length is 6, and it has equal number of zeros and ones. Like you can see there is 1 2 and 3. There are 3 number of zeros and there are 3 number of ones, right? So this is the thing in this question. Like you can see the number of zeros and number of ones are equal, so you have to find the length of the longest subarray which is consisting of zeros and ones, right? Is this part clear to everyone? Is this much part clear to everyone about the problem, right? In this problem what you have to do is you'll be given a binary array that will be consisting of zeros and ones, and what you will be doing in this particular question is that you will be finding the length of the longest contiguous subarray which is consisting of equal number of zeros and ones. Like if in this case I tell you about this question like 0 1, let's say 0 0 0 and something like this. So in this case you can say that the length of the longest subarray which is having zeros and ones equal number is 2, right? This is the length because there's only 1 1 and 0, right? So you can say that this is the longest length. Let's look at some of the test cases. So if I look at the test cases, so you can say like 0 1 and 0. If I take this thing, so what does it mean? Like if I have 0 1 and 0, here also the length of the longest subarray which is consisting of equal number of ones and twos, zeros and ones is 2, right? The length is 2, right? Is the problem statement clear to everyone? We'll check the contiguous array. If double 1 1 or double 0 0 appears, we will restart the counter. Brute force approach. No, this will not be the brute force approach, Lalit, Shreya and others. Is the problem statement clear to everyone? If the problem statement is clear to everyone, please write clear in the chat and then we'll proceed further, right? So if the problem statement is clear to everyone, like you will be given an array and you have to find the length of the longest subarray. You will be given an array and you have to find the length of the longest subarray which is having equal number of zeros and ones, right? Given an array, find the length of the longest subarray which will be having maximum equal number of zeros and ones. Like if I consider like this, something like this, 1 0 0 1, something like this. So if I am considering things like these, or maybe any other example, maybe like this, right? So in this particular case what will happen? This will be my answer, right? This particular thing would be my answer, this particular subarray, because it is having two zeros and it is having 2 ones, right? So that's why this would be the answer. Total length would be 4, right? Is it clear to everyone else in the chat? Shreya and others, I hope that it's clear to everybody, right? This question, because it's an easy one, right? So now moving on to with this question, what I can do is, since I have to find that what is the length, I have to find what? I have to find the length of the longest subarray, right? I have to find the length of the longest subarray having equal number of ones and zeros, right? Having equal ones and zeros, right? This is what I have to find, right? Is the question clear? Right? This is what I have to find, right? I have to find the length of the longest subarray having equal number of zeros and ones. So what I can do is, can I say that if I have to approach it in a brute force manner, or I'll say that approach 1 that I can think of is to generate all the subarrays, right? Generate all subarrays, right? generate all the subarrays and count the number of ones in it and the number of zeros in it. If the number of ones and zeros are equal, so I store its length, and every time I keep on storing length of such, like I keep on checking with the maximum length, right? Like what I can do is I can maybe, let's say I have some elements, right? I have some elements like this, possibly like this, right? So assume that the elements are zeros and ones, right, as it has been mentioned in the question. So what I can do is, first of all, I can keep my I here and I can start my j from this index until here, right? And like I can check it with this and this, right? I can first of all check with this subarray, then I can check with this and this, then this and this subarray would be generated, then this subarray, then starting from this to this and starting from this till the end, right? Like this. Then I can keep my I here, and if I keep my I here, so this subarray, then this would be one subarray, then this would be one subarray, then from this index this would be one subarray, then another subarray would be from here till the end, right? This is how I can generate all the subarrays. So basically I can to generate subarrays you can make n cube loop as well, but that's not like you can do it in n square as well. So that's why we will prefer to do n square, and if we do it in n square, then we can generate all the subarrays, and then what we do is we can count the number of high above, right? So what we do is we basically count the number of zeros and ones in the subarrays that we generate, and whichever subarray is having the maximum length, we keep that, right? We print the length of that subarray, right? So what I'm saying is, let me show you the code part for it. Like it's very easy. Like basically what you have to do is you just have to first of all keep a maximum length, right? After this, what you do is you iterate first of all through I starts from 0, I is lesser than n, so you keep a pointer I which would be fixed initially, right? As I told you, it first of all I would be fixed to the 0, then j would be moving one by one, right? Like this. So you keep a counter. Every time you are doing this, you keep a counter of zeros is equal to 0 and ones is equal to 0, right? And what you do is you start your j from I, as I told you, and you iterate until the end, and you check for all the subarrays, right? Every time you will be checking for the subarrays. You can do this in n cube as well, but n square is better, so you can do it in n square. So why not n square, right? So what you do is, if the current number is 0, if the nums of j is 0, then you count the 0 plus plus, then you increment the number of zeros. If it's a 1, so you increment ones, right? You increment the count of 1, and if the number of zeros and the number of ones is equal, right? If let's suppose that you are at a particular subarray like this, if you are at a particular subarray like this, like suppose this is my subarray, if I am at this index, I is here and my j is here, right? And the number of zeros and ones are equal. Let's say this is the situation, right? So in this case, I can see that I have two ones and 2 zeros, right? So I can see that it's equal. Let's do the indexing part. So this will be index number 0. This would be index 1, 2, 3 and 4. I can see that the indexing is this. So if I say that j is equal to 4 and I is equal to what? I would be equal to nothing but 1. So if I do j minus I, what will I get? I'll get 4 minus 1, that is nothing but 3. But actually there are 4 elements. The length is 4. The length here is 4 and not 3. So that's why I'll do a plus 1. Right. So that's why I'll do j minus I plus 1. That will give me the length of that particular subarray which is having equal number of zeros and ones, and by doing that I can always keep a maximum. Initially I can mark my maximum to 0, and I can always keep a check that maximum is equal to nothing but mx is equal to nothing but maximum of like something like this, right? Let me write it down. So I can do this, mx is equal to nothing but maximum of mx comma j minus I plus 1 if the particular subarray which is starting at I and ending at j, if it is having equal number of ones and zeros, then I can always update my maximum length, right? Is this part clear to everyone? If it's clear to everyone, please write clear in the chat. If this particular approach is clear, right? It would take order of n square approach, because what I was doing was add a subarray like this, right? So I fixed my I here and I moved a j. So first of all, j would be here till here, then j would be from here to here. Then I'll consider this subarray, then I'll consider this subarray, and then this subarray, right? Similarly for this, if I keep my I here, then this would be the first subarray, then this would be the second subarray, this would be the third subarray, this would be the fourth subarray, like this, right? If I am here, so this would be the first, this would be the second subarray that I will be considering, this would be the third array that I will be considering, right? Is this much part clear to everybody? Is it clear to everyone? Just let me know in the chat, and also like the video if you have just joined, right? Is this much part clear to everyone? I hope that it is right. If it's clear, you can consider giving a +1 in the chat. What I'm saying is you are generating just all the subarrays. What you are doing nothing but generating all the subarrays. You can do it in n cube as well, but n square is better. So why not n square? So you generate all the subarrays. Basically, you iterate through all the subarrays, and if a particular subarray is having equal number of zeros and ones, then the subarray is ending at j and starting at the index I. So its length would be j minus I plus 1, as I told you. So always you keep a maximum and you keep a track that if that length that you're getting, if this subarray that is having equal number of zeros and ones, if it is having the maximum length, so you update your length. Otherwise you always keep a track of the maximum, right? And in the end you just return the maximum length, right? So this outer loop would be running order of n times, and the inner loop, which is starting from j until the length, it will also be running in the worst case order of n times. So that's why order of n square approach, right? If this much part is clear, so you can write clear in the chat so that we can move towards the optimal solution of this question, right? Because still the question isn't very much clear to us, right? Still the question is clear, but still like it will be a little bit difficult task to think like how we have to go for the optimal approach, right? If this much part is clear, so you can give me a +1 in the chat, because I am not sure why I'm not receiving your chats, right? What you can say is that if I say that I have, let's say 0 1 and let's say I have 1, something like this, right? How will I say, how can I do it in order of n time? Can I do it in order of n time? I can do it in order of n cube. I can do it in order of n square. Now can I do it in order of n? Right, that's the case that lies ahead. How will you think to do this question in order of n? Right, what you can do is, how will you say count, right? The factor is that if you will generate all the subarrays, then it becomes very easy. You can give me a +1 in the chat if you are there in the chat, because I am not sure why I am not getting the comments, right? So what I'm saying is, basically if you will see, so if you generate all the subarrays, then it's very easy to keep a track of the zeros and ones, right? But if you are not having the track, if you will not keep a track of the count of zeros and ones, in that case it would be very difficult. Now when you see this question, so you'll think that maybe there's a concept of sliding window or something like that, right? You will think that maybe we have to apply a very complex type of implementation which would help us to do this in order of n. But believe me, that is not the case for this question. Why? Because what I'm saying is that how will you see that whether the number of zeros is equal to number of ones, right? That is the question that lies ahead. How will you know that the number of zeros is equal to the number of ones? That is the situation that is very much important for you. So what you can do is, if you have a 0 and you have a 1, so if you have a 1, that's perfectly fine. But if you have a 0, right? If you have a 0, then you indicate, if you have a 0, then you just represent it as -1. If you have a 0, so you think of it as -1, right? What I mean by that? So what I mean is that if you see at this particular example that I am drawing, if I draw 1, 0, 0 and 1, something like this, and what I'm saying is you represent all the zeros with -1s. You represent all the zeros with -1s. So this is 1, this is -1, this is -1, and this is 1, right? This is the case. Now you take the prefixSum. Okay, so up till here the sum is 1, so you'll say okay. Now up till here the sum was 1, right? The prefixSum up till here is 1. Okay, that's perfect. Now till here, till this index, the prefixSum would be 1 minus 1, so it would give me 0. Now what does it tell me? Whenever I encounter a sum 0, now you can see that here I have encountered a prefixSum as 0. If I am encountering a prefixSum as 0, so does that indicate that if representing this particular array 1 0 0, I am representing it like this: 1 minus 1 minus 1 and 1. If I am representing it like this, so that means I do not have any 0 in my array, right? If I do not have any 0 in my array, but still I am getting a prefixSum as 0, so that basically indicates that there would be equal number of zeros and ones in it, right? Right? Okay, so there was some issue, right? So there would be some equal number of zeros and ones, right? You can give me a +1 in the chat if you agree with me, right? Up till here. this is what I'm saying. Now the thing is that I have equal number of zeros and ones, right? So what I was saying, yeah, here, this part. So what I'm saying is, if I have equal number of zeros, like if I have equal number of zeros and ones, so that means my prefix sum would become 0, like here you can see. Now let's add, right? Let's add. So here my sum would become -1, here my prefix sum would become -1, here -1 plus 1 would give me 0. So you can see that this is one of the instances and this is one of the instances where I am getting a 0, right? Is this much part clear to everyone? If this much part is clear, you can give me a +1 in the chat, right? There was a little bit of internet issue, but you can just give me a +1 in the chat if up till now things are clear to you guys, right? Okay, is it clear to you? I hope that it is clear, right? Yeah, right, Mahesh, it is clear to you. So what I'm saying is, like if you will look at this particular example, so can I say that if I mark this indexing as 0, like this indexing as 0, let me first of all draw, like this is 1, this is -1, this is -1 and this is 1, right? So let me bring the indexing part. So the indexing here is 0, indexing here is 1, indexing here is 2, indexing here is 3, right? I'm going with the 0 based indexing. So I'm going like this. So what happens is my sum is what here? Prefix sum, right? My prefix sum is what? My prefix sum here is nothing but, here it is 1, here the prefix sum is 0, here the prefix sum is -1, and here the prefix sum becomes 0 again. So can I say if I am getting a prefix sum as 0 here, so that means at the index number 1, if I am getting a prefix, if this is 0 based indexing, so that means I could have got at the index 2, I could have got, right? So that means 1 and 0 would have been an option for me. So here the length would have been what? The length would have been I plus 1, right? So this could have been my length. So if I plus 1 is my length, so I is 0, so that means my maximum could have been 2, right? The maximum could have been 2, right? Maximum could have been 2. But what I want to say is, I also have a 0 here, right? If I have a 0 here as well, so that also indicates that I might I'll have a array which is having up till here, which is indexed till 3, right? This is 0, this is 1, this is 2, this is 3. So till this index I am having an array which is having equal number of zeros and ones. So this is nothing but, if this is I, so I plus 1 is the length. So that means this is I plus 1 is what? If I is 3, so I plus 1 is 4. So this subarray is of length 4, this subarray was of length 2, so I'll update my maximum to 4 like this, right? Is this much part clear to everyone? Up till now, if things are clear, then you can give me a +1 in the chat so that I can proceed further, right? If up till now things are clear to you guys, then you can give me a +1 in the chat, right? Okay, perfect, right? What I want to say is that if I want to ask you something, right, there can be a lot of scenarios, right? But let's say that if up till here, if up till this index, this is some array, right? Suppose that this is some array, okay? If the sum from here till here is sum, right? If from sum from here till here is sum, and the sum, if this till this part the sum is sum, or you can say, let's say if I take this much part, if the sum from here till here is sum, right, and the sum from the starting till this point is also sum, so what is the sum of this part? What is the sum of this part? Can you tell me? Can you tell me what is the sum of this part? If the sum of this particular element till this particular element is, if the sum of this particular element till this particular element is sum, and the sum of the array till this index is also sum, so what is the sum of this part? Can I say that the sum of this part is nothing but 0? Sum of this subarray is 0. Can I say this? Can I say this? Can I say this? Please give me a +1 in the chat if this much part is also clear to you guys, right? If this much part is clear to all of you, you can give me a +1 in the chat, right? Is it clear? What I'm saying is, if I have an array, and if let's suppose that the complete sum of the subarray, if this complete sum up till here is sum, and if this much part also is sum, if the sum of this much part is also sum, then what is the sum of this part? What is the sum of this part? Can I say that the sum of this part is nothing but 0, right? I can say this. I can say that the sum of this part is 0, right? I can say this. Is it clear to everyone? If it's clear in the chat, you can give me a +1 in the chat, right? If it's clear to everyone. Is it clear? Okay, Mahesh, it's clear. And what about others? Others is also okay, it's clear, right? So this is the thing. Can I say that if I put an observation on this, that if up from here till here, if let me just write it again, right? Yeah, if from here till here I have sum as sum, and from here till here I have prefix sum as sum, so that would simply indicate that this much part would have a sum, zero sum, right? And if this much part is having a zero sum, so if I am representing like this, and if this much part is having a zero sum, what does it indicate, right? What does it indicate? If this much part is having a zero sum, so in this case, can I say that this is also one sub array? This is also one sub array which is having equal number of zeros and ones, right? Equal number of zeros and ones. Can I say this? If this much part is 0, if this much subarray is 0, as I've concluded, if the sum from this much part till this much part is sum, and the sum of this much part till this much part is also sum, so that means this part till this part is 0, the sum of this much part is 0, overall sum of this much part is 0, and that means that if I was representing 0 with -1 and 1 with 1 only, right? So that's why I'll get a sum 0 here. So if I'm getting a sum 0, so that means that this subarray, this particular subarray, internal subarray, will have equal number of zeros and ones. Do you agree with me? Please write agree in the chat if you agree with me on this much part, right? If you agree with me on this much part, you can write a +1 in the chat, right? You can give me a +1 in the chat if you agree with me on this much part, right? Do you agree? Do you agree with me? I'm waiting for your comments, right? You agree with me, right? That what I'm saying is a little bit of internet issue is there, so that's why the stream is not smooth as it was till yesterday. So I'll fix it today, right? What I'm saying is, if I have this array, right? If I have this particular array, right? So if the sum here, so that means that the sum of this much subarray, this particular subarray, would be what? This much subarray sum would be 0, and if it's 0, so that means I am representing 0 with -1 and 1 with 1, so that means this subarray will have equal number of zeros and ones, right? Yes, everyone is agreeing with that. And if this much part is having equal number of zeros and ones, so then in that case I can also consider this, right? I can also consider this. So if either my prefix sum is 0, or if I see some part which I've already seen, in those cases I can say, right? Now what does it mean, right? What does it mean? So let me draw an example for all of you, right? So that you can understand it a little better. Let's say if I had something like a 1 1 1, then let's add -1 -1 -1, and let's say then I had something like a 1 1 1, like this, right? If I had something like this, so this is the nums array that has been given to me, right? So I'm representing 0 as -1, okay? I'm representing 0 as -1, so that if the prefix sum becomes 0, so that will indicate that the length is something like that, okay? So what I'm saying is, let's see what is the corresponding prefix sum to it, right? Let us see what is the corresponding prefix sum to it. So if I see, so the prefix sum here is 1, the prefix sum here is 1, right? And the prefix sum here is also 1, right? The prefix sum here would become the prefix sum here would become would be 2, right? And the prefix sum here would be 2. Mean that I have something. Does that mean that indicates something? This is 1 1 0 0 0 0 1 1 1. So does this indicate something? If I had this sum, if I had seen this sum earlier, if I had this sum 2 earlier, right? This sum 2 was occurring earlier, this sum 2 is occurring again. So does it indicate something? Can you look at this? If you look at this, can you look at the array? Can you look at the array? This particular subarray, right? This particular subarray. Look at this particular subarray. This is the original array. I am representing zeros with -1s, right? Can you look at this? Can you observe this, right? That till this, your sum was 2, till this index, the prefix sum here is also 2, so that means that in between the sum is 0, right? What does it mean? 1 1 1 and -1, right? What it is saying is that if till this much part the sum was 2, and for this much complete part also, for all the elements also, like for this much complete part, let me draw it again for all of you, right? So what I'm saying is that if I have 1 1 -1 and 1 1 1 and -1, something like this, right? Okay, sorry for a little bit of interruption. there's some issue with the power electricity, so that's why we are having this issue, but don't worry, I'll fix it in the next time. Okay, so if I have this particular subarray, right, if I have, let's say 1 1 1 and minus 1, right, so if the sum up till here is what, the sum up till here is 2, and if you look at this completely, so sum here is also 2, right, sum here is also 2. If that is the case, so that means that the sum for this particular part, right, stream not working. I hope that the stream is working now. Is it working now? A little bit of issue is this, so sorry for that. Light issue is there, so I cannot do much about it. So this is the part, right, this is the part that we have. This part is having what? This part is having a sum as 0, right? Because if I had the sum as 2 here and the sum as 2 here, so that would simply indicate that this much part of sum is 0, and if this much part of, I hope that it's working. Is it working? Okay, right, so up till now I can say it's working. Yeah, it's working, right? So up till now what I can say is that the sum was 2, prefix sum is 2. Now I'll go here and the prefix sum would become 1, right? The prefix sum here would become 1, because if I add another minus 1 to it, so the prefix sum becomes nothing but 1. Now here if I have seen 1, right, if I've seen 1, have I seen 1 earlier? Yes, I have seen 1 earlier, right? I've seen 1 here and I can see 1 here. So that means that there's something that's of my concern, right? There's something that I can do with it. What I can observe is that the sum up till here is 1 again. So if I take out this subarray, right, this particular subarray which is starting here and ending here, right, this particular subarray, okay, so 1 1 1 and 1 1 1, and then what's the part? 1 1 1, and like I had this much part, right? I was not discussing about this part. Basically what I'm saying is, if I have this much part, so that indicates that this much part, right? So if I have the sum again, this, right, now I'll have the sum as, have I done some mistake here? I think so. I might have made some mistake, but no, I haven't made a mistake. So that is the sum would be here nothing but 2, the sum here is 1, the sum here would be 0, right? So I can say that if the prefix sum itself becomes 0, right? Thanks a lot, Ritik. Right, so if the sum here again becomes 0, if the sum here becomes 0, so what will happen? If here my sum is becoming 0, so that simply indicates that if the prefix sum itself becoming 0, so that means that this particular length is also having equal numbers, right? So I have 1 1 1 minus 1 minus 1 and minus 1 till here, right? So like this till this indexing, right? You can talk about the zero based indexing. So the index would be I plus 1, basically the length would be I plus 1, right? So for this particular length you can see that I have the equal number of zeros and 1, because these minus 1s are indicating nothing but zeros, right? So that is why I have 0 0 0 and 0, right, like this. So this is also one of the answers. Now if you will move ahead, then what happens? So let's say you are moving ahead, right? So if you update your answer, so this was 1, this was 2, and this was 3, this was 2, this was 1, this was 0. So this is 1, this is 1. Now if I encounter 1 here as well, right, if I encounter 1 here as well, so what does it indicate? If I'm encountering a 1 here as well, what does it indicate? Look at this particular subarray, right? The last time I encountered a 1 was here. So just take out this particular subarray, look at this particular subarray. 1 1 0 0 0 and 1, right? So it's nothing but this, right? This subarray that I am talking about, this subarray. 1 1 0 0 0 is indicated by minus 1, so 1 1 and minus 1 minus 1 minus 1 and 0, like that, like this. So can you observe that here also you have equal number of zeros and 1? If I represent zeros with minus 1s, then only this particular part, like 1 1 minus 1 minus 1 minus 1 and 1, so ultimately the sum would be 0. So that's why I'll have this part as well, and you can see that this sum is repeating, right? This sum is repeating, this particular prefix sum is repeating. Since this particular prefix sum is repeating, that is the reason, since this particular prefix sum, right, I had the sum here, I had the sum, this sum, right, I had this sum here, and I have this sum here as well. So that means that this much part is there, which is having a prefix sum 0, right, which is having this much internal subarray is there, this internal subarray, that is 1 1 0 0 0 0 0 and 1. Please give me a +1 in the chat if up till now things are clear to you guys, right? Because I know that because of the electricity issue there have been a lot of delay or something like that. But like, is it clear to you guys? Like, you can see that the sum here was 1, the sum here was 1, so that means this subarray in between this, so from this index till this index, you can see that the subarray is nothing but having equal number of ones and zeros. So that is why this is having internally the sum as the same, right? This is what I said, this is what I told you, right? This is what I told you guys, that if I have this particular subarray, right, if I have this particular array, and if the sum from here till here is sum, and the sum of this part, this much part is also sum, so that means that the sum of this much part would be 0, and I do not have any 0 in my array. So that's the reason for that, is basically because the ones and the minus ones are equal, and minus ones represent 0, so that's why it ultimately indicates that the sum here is 0, because there are equal number of ones and minus ones. So if there are equal number of ones and minus ones, so that would simply mean that I have what? I have basically equal number of ones and minus ones, and I can consider this length, and this length would be what? This length would be nothing but if I am able to do the indexing part. So let's see what I'll see when I get the indexing part, right? So let me do the indexing part. So this is index number, let me write IDX. So this is index 0, 1, 2, 3, 4, 5 and 6, right? This is the index 0, 1, 2. You can give me a +1 in the chat. A little bit of acknowledgement from your side would help, because I am trying to explain it with a lot of detail, right? Like Shreya, Mahesh, Nav, Lalit, Ritik, all of you can just give me a +1 in the chat. A little bit of acknowledgement, right? That it's that the things are working for you guys, right? So if I have up till here, right, if I have the indexes here, so what do I see? I had seen this at this particular index, right? I had seen a 1 at the index 0, right? I had seen a 1. Okay, thanks a lot, right? Yeah, right. So if I had seen a 1, at the index 0, right? If I had seen a 1, if I had seen sum is equal to 1 at the index 0, and I can see a sum 1 at the index 6, right? I can see a sum is equal to 1 at the index 6. So if both of the indexes I subtract, then what is the length that I am getting? If I do this, the index at which I was getting 1, notice that this length was also there, right? This length was also there, but this is not the largest, like this and this. Here also it is same, so 6 minus 4 would be 2, and here you can see that this is the subarray, right? This is the subarray, but like that's not the case that we are considering here, right? So like this subarray 0, 1, so this is the subarray. Otherwise this subarray is also there, right, where I have this thing, where I have this particular thing, right? That is this. Yeah, hi Vanshika Kapoor. A little bit late, student. Okay, so this is the index. This is index 6. This is index 1. Both of them are having same sum. So that means if I that means that the sum of this internal part would be 0, right? Because if the sum here was 1, and in between this, after this also I am adding a lot of values, but I am getting the sum as 1 again. So that means the internal, all the sums is 0, right? So that means nothing but 6 minus 0. The indexing 6 minus 0 would give me 6. And what is this length of this subarray that I had? This subarray was nothing but 1, 1, 0, 0, 0 and 1. This particular subarray, right? This particular subarray that I was talking about, like this particular subarray, you can see, right? Starting from here till here, right? Till here. That is what I was talking about as well. That is which is having equal number of ones and zeros, right? So this I indicated with this part, right? So that's why its sum is 0, right? So that's why this subarray we also have to consider. So that is nothing but if in a map I keep a track of the sums that I am getting earlier. If in a map or a vector I keep a track of the sums that I have got earlier, right? And then if I am getting that particular sum again, right? That's the concept behind it. That there could be two things, right? There could be two things. That if my prefixSum is 0, right? If my prefixSum is 0, so that means that the length of the subarray would be I plus 1, right? Then the length would be I plus 1, right? Then one of the candidates for the length would be I plus 1. That's completely fine, right? That's completely fine. But this is the only part. This is not the only part, right? You also have to consider a lot of internal subarrays. And how will you check that? For internal subarrays, as I told you, like if the complete subarray up till here is having a sum, if up till here the sum is sum, and I have seen that particular sum earlier as well, so that means that is sum of this particular part. This particular part, the sum is 0, and if I am representing zeros as minus ones and ones as ones, so that means there is a sum 0 only because the number of ones and the minus ones are equal. So that means the number of zeros and ones are equal. So that means that I can have to consider this length as well. Understood? Plus. Thanks a lot, Ritik, right? So that's why it is the case. So that's why what I'll do is, every time I encounter a particular sum for the first time, like I have encountered this particular sum prefixSum 1 for the first time, right? I'll not consider this. While I'll not consider this one, why I'll not consider this one? Because I want to find the largest length. I want to find the largest length. So that is why I'll not store this index of 1. This index of 1 I want to store. Why I want to store this index of 1? Why I want to store this? Because I want the largest length, right? This till here would give me the largest length. If I keep on updating my index of 1, the sum of 1, in that case this and this would be the answer, but that's very short, right? I want to keep it as long as possible. So whenever I see it for the first time, that is when I will be storing in my map. So I'll say map of 1 is equal to nothing but 0, and then once I get the sum 1 here again, so that means I'll do 4 minus map of 1. Right, 4 minus map of 1 would be nothing but 4 minus 0, and that would be the length that I need to consider as well. So length would be nothing but, if at the ith index I am getting the sum again, if at the ith index this particular sum, if there is a sum that is already existing in my map, if at the ith index there is a particular sum which is already existing in my map, like in this particular case, if my I was equal to 4, and here the sum is already existing, right? Like here this sum is already existing. So if at a particular index I, if the sum is already existing, so in that case what I'll do, I'll say that one of the candidates for length is nothing but I minus map of sum, if that particular sum is already existing in the map, right? So like this, so it would be nothing but 4 minus 0, so the length candidate would be 4, but another candidate could have been like this, right? Another candidate could have been this. If once my I moves to this, suppose my I moves to 6, right? If my I moves to 6, so if my I is moving to 6, so I is equal to 6, right? So at I is equal to 6, I am getting a sum which is what? The sum is what? The sum is nothing but 1. The sum is 1. At I is equal to 6, the sum is 1, and at I is equal to 0 also the sum was 1. So that means the length, possible candidate for the length is also, length is equal to what? I, that is I is 6, 6 minus map of 1. Map of 1 is what? Map of sum, right? Map of sum that I have repeated just now, right? So at the index I is equal to 6, I am having sum which is 1, and at the index 0 also I had a sum, so that's why in the map it is stored. So that's why it would be nothing but 6 minus 0, so I'll get the length 6. So these are the internal subarrays as well that I need to consider, as I told you, right? This internal subarray which is having equal number of ones and zeros, right? This internal subarray, and things like these, right? Things like these, right? Is it clear to everybody? Is it clear to everyone? Just let me know in the comments, right? Is this much part clear to everyone? Like what I am doing is, I am having a map in which I am storing all the indexes of the sum, right? So I've made a map to store all the prefix sums, right? All the prefix sums. And if a particular prefix sum is occurring earlier as well, then in that case I'm just doing I minus map of sum, right? If a particular sum I have already stored, because that would simply indicate that if up till this part, if I'm having sum, right? If at the ith index I'm having sum, and earlier at this particular index I also had sum, so this particular index would be stored in this particular index I'll store in the map of sum, right? In the map of sum I'll store this particular index at the very first time whenever I saw this particular sum, right? So that means that this particular part that I have, its sum is 0. So that means if its sum is 0, and considering that I am representing a 0 with a minus 1, so that means that this much part is having equal number of zeros and ones. So that simply indicates that I have to consider this subarray as well. So that its length would be nothing but I minus I is the current index minus the MP of sum, at which the index at which I got the sum for the first time, right? This particular prefix sum for the first time. So this would give me this length, and I also need to consider such subarrays, right? Internal subarrays. If this part is clear to everyone, please give me a +1 in the chat. I hope that it was clear. Now talking about the time complexity. So since I am iterating through the array only once, since I am calculating only the prefix sum every time, so the time complexity would be order of n, and I'm using a map. You can also use a vector, that depends on you. So the space complexity of this particular approach, since I'm using a map to store all the prefix sums, so that's why it would be order of n as well. Let me show you the code part for this particular problem so that you can understand it a little better. What I've done is, this is nothing but if the particular number is 0, then you are adding, like, let me write this part for you as well, right? What they are saying is, if my nums of I is equal to 0, right? If my nums of I is equal to 0, in that case what will I do? If my nums of I is equal to 0, in that case I'll add in my sum. What will I add? I'll say sum plus is equal to -1, right? Sum plus is equal to -1, right? I'll add a -1 to my sum, right? Else what I'll do? Else I'll let me write it like this. Else if the sum, if this is not 0, so that means I'll add 1 to it, right? So I'll write nothing but sum plus is equal to 1, right, like this. So I'll add 1. So this is what I was doing. So this is nothing but the prefix sum that I am calculating. If the, this is what, if I'm iterating through the array and I've made a map. So if I'm iterating through the length of this array, if the number is itself 0, so I have to represent it with -1. So that is why instead of adding 0, I'm adding -1 to it, right? Because only then, if the prefix sum becomes 0, only then I'll be able to see that the number of zeros and ones are equal, right? Only then I'll be able to observe it. And else if the sum is equal to 1, so then I'll if the number is 1 itself, so I'll add 1 to the sum. If at any chance my sum becomes 0, if the prefix sum itself becomes 0, so that means the length of that particular subarray would be I plus 1. That particular subarray's length would be I plus 1. So I need to check the maximum with that. Apart from this, if that particular sum, if that particular sum is already existing in my map, if this particular sum is already existing in my map, so that means that if it is already existing, then that means that the length at the current index I, the sum is sum, and at the MP of sum index, the index at this particular index also, add this sum. So I'll subtract the length, so I minus map of sum, as I have explained you in the dry run as well. So mx is equal to nothing but maximum of mx comma I minus MP of sum. Else what I will do is, if the particular sum is happening for the first time, so in that case I'll say map of sum is equal to I. So I'll store it so that the next time I can use it, right? Is this much part clear to everyone? You can like the video. First of all, I can see a lot of people are watching till the end. So almost we are 50 minutes into this particular stream. So please like the video and please give me a +1, right? If this much part is clear to all of you, please like the video and please give me a +1 in the chat. You can like the video, okay? We are 50 minutes down the line. So you can like the video and you can give me a +1 in the chat, okay? So this was the problem. Previously, good explanation. Thanks a lot, Nav. Okay, thanks a lot, Nav. You can recommend this video to your friends. Like I tried to explain it a lot. You can recommend this to your friends to watch at maybe 1.5x or 2x if they want to learn from this. Like the thing is that I am not here just to explain the editorial or just to give you the solution, right? I want all of you to understand the intuition behind it, right? Right, that's the concept that I want to evolve in all of you. So you can consider to like this video, subscribe, and make sure to share it with your friends as well. Now tomorrow, what I want to say is, tomorrow we'll have a bi-weekly contest, LeetCode. So I'll be making editorials of that. Apart from this, we also have a weekly contest of LeetCode Sunday, this Saturday, this Sunday. So all those videos will be coming, and we have a codeforces contest as well. So I guess it is on 6th. So we'll also be having, I'll be making its editorial as well. So these are the editorials that I've planned. Apart from this, if you think anything else that we can do for you, so you can comment after this video is over. You can comment down below that what are the things that you think that we can do so that you might get some help, because this is an initiative that where we are trying to grow you, right? We are trying to help you in increasing your problem solving capacity, right? So this was the problem. Like as I said, this was the code. If the number is 0, so you're representing it with -1. So in the sum you add, in the prefix sum you add -1. Otherwise, if the number is 1 itself, so you add sum plus is equal to 1. If the prefix sum itself becomes 0, so that means the number of zeros and ones are equal. So the length of that particular subarray would be I plus 1, because it will be from the starting and the indexing is 0 based. So that's why you need to do I plus 1. Otherwise, if that particular sum is already existing in the map, so that means that a particular segment of the subarray would be having sum 0. So if that is the case, so the current index is I, and for very first index at which we must have seen this particular sum would be nothing but map of sum. So I minus map of sum would be the length. So I'll keep a check on the maximum. So if this length is maximum, I minus map of sum. So in that case, I'll update it. Otherwise, if this particular sum I'm seeing for the first time, so in that case, I'll write map of sum is equal to I, and in the end, I'll return map my maximum, right? If it's clear to everyone, please for the one last time, please write clear in the chat. I'm here for 60 seconds more for all of you. If you want to ask anything or if you want to say anything, you can say. Otherwise, I'll end this history, right? If you want to say something, if you want to ask anything, so you can ask or say. Otherwise, I'll definitely end this stream now, because we are 50 minutes into it. So also one more thing, like after this stream is over, so we'll update the timestamps, right? We'll update the timestamps for this particular video. You can consider to share it with your friends and ask them to watch at 1.75 or 1.5x so that they can have a better understanding. Thanks a lot for watching this video, guys, and I'll see you soon in the next live. Till then, take care and happy coding.